So we have Chapter 5, Review for the Test. So we're going to go through each problem. So number 1 says a force of 80 newtons. And again, as you're reading the questions, you just want to see, you can underline important thing, pushes a 50 kilogram object across a level floor in 8 meters. What's the work? So first of all, I know work is equal to FD. So you notice they give you a mass and they give you an applied force. Remember, work is only done in the direction in which an object moves. So W is equal to FD. So you have the 80 Newton force times 8 meters is 640 joules. So this 50 kilograms, we don't need that information. Number 2. A 500 Newton girl lifts a 10 Newton box vertically a distance of 5 meters. The work done on the box is, so work is equal to FD, and we want the work on the box, so it's 10 newtons times 0.5 meters, which is 5 joules. So the girl's mass is not being displaced. So when we read these questions, we have to be careful with what we're reading. Number 3, as shown in the diagram below, a child applies a constant 20 Newton force along the handle of the wagon, which makes an angle of 25 degrees with the horizontal. How much work does the child do moving the wagon a distance of 4 meters? So this was number 1. This is number 2. Number 3, so this is also work. So the child is pushing the wagon in this direction. So the displacement in that direction is 4. So the work is going to be the horizontal component. Remember components? This horizontal component of this 20 Newton force. So work is going to be FD cosine theta, which is going to be 20 newtons times the cosine of 25 degrees times 4 meters. So the work comes out to be 72.5, but if we look at correct significant figures, which is 2, that's going to be 73. So you have to remember on multiple choice questions, the answer is going to always be in correct significant figures. All right, number 4. If 20 joules of work is done in 4 seconds, what's the power? So power is work divided by time. So 20 joules divided by 4 seconds, and a joule per second is a watt. Again, when you're reading the question, you can just circle what you're given. Maybe for here, I just want to say this is W, this is T. I can put my variables in. That'll help me to identify what everything is. All right. And again, we can put our answer choices in here. So number 1 was 640, which was A. Number 2 was 5, which was B. Number 3 was 73, which was D. Number 4 was 5 watts, which is A. All right, number 5. As the time required for a person to run up a flight of stairs increases, the power developed by the person. So we did a lab like this. We actually did this. So the first thing I'm going to do is I'm going to write my basic equation. And I know that power is equal to work divided by time. So now the question is saying, as the time to run up a flight, as this increases, what happens to this? So as this increases, now what's happening to this? Well, this is in the denominator, so if this is getting bigger, that means this is getting smaller, so this is going to decrease because they are inversely proportional in the equation. So I just write the equation down and then I look at it. So the answer here is A. Number 6. A cart has a mass of 2 kilograms and moves at a constant speed. Remember, constant speed is always important because that means there's no acceleration, of 4 meters per second. What's its kinetic energy? So kinetic energy is 1/2 mv squared. So it's going to be 1/2 of 2 kilograms times 4.0 meters per second squared. So 16, and then actually the 2 and the 1/2 will cancel each other. So it's just going to be 16. So that's going to be choice B. And again, if you forgot to square the velocity or something like that, that's the most common wrong answer is always going to be a choice. All right, number 7. As an object moves upward at a constant speed, what happens to its kinetic energy? Well, if it's moving at a constant speed, that would be constant, so it would remain the same. Number 8. What is the gravitational potential energy with respect to the surface of the water of a 75 kilograms, so I know that's the mass, diver located 3 meters above the surface, so that's the height. So we know that potential energy is equal to mgh. So it's 75 kilograms times 9.8 meters per second squared times 3 meters. And when I put all that in my calculator, the calculator is going to say 2205. But I don't see that in my choices because that's going to be in correct significant figures. So this is 2, this is 2, that's 3. So my answer has to be rounded to 2 significant figures. So this would be 2.2 times 10 to the 3 joules, and that would be 2.21 would be 3 significant figures. So that's going to be B. Unless they... All right, so that's number 8. All right, let's go on and do the other side. Number 9. Guess I'll use some fresh paper. So we can see this over here. Okay, so number 9 says, which mass has the greatest potential energy with respect to the floor? So we know that potential energy, so we're doing number 9, is equal to mgh. So what I'm going to do is now all of these are going to be m times g times h. So since g is the same, just multiply the mass times the height because they're all going to be multiplied times 9.8. So why bother doing that? Okay. So when we look at this, we'll just say, okay, 50 times 0, because it's on the floor, is 0. 2 times 10 is 20. 10 times 2 is 20. And then 6 times 5 is 30. So this is going to be our answer. All right, number 10. It says, base your answer to the following questions on the diagram below, which represents a simple pendulum with a 2 kilogram bob length of 10 meters. The pendulum is released from rest at point 1 and swings without friction to point 4 through the position of 4. At 3, its lowest point, the speed of the bob is 6 meters per second. So it says, compared to the sum of the kinetic and potential energy of the bob at 1, the sum is. So we learned that with conservation of energy, the total energy is going to be the same. So whether it's here, 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 the sum of the potential and the kinetic are always going to be the same. So this is just the same. All right, number 11. It says a ball is thrown vertically upward. As the ball rises, the total energy. So remember, the total energy, not the potential, not the kinetic, the total energy is going to remain the same. If I'm throwing it up and it starts to slow down because gravity's pulling it down, whatever I lose in kinetic, I'm going to gain in potential. But the total energy is going to remain the same. All right, number 12. A 20 kilogram object strikes the ground with 1960 joules of kinetic energy after falling from rest. How far above the ground was it? So this is just like the problems we did when we did conservation of energy. So we know that the energy, the total before is equal to the total after. So KEI plus PEI is equal to KEF plus PEF. So initially, this is at the top. If it's being dropped, the velocity is 0 because it starts from rest. So this is 0 plus this is mgh, and the potential energy final is going to be 0. So this is equal to KEF. So KEF is equal to mgh. So now I want to solve, I just want to solve for KEF. So it's just going to be mgh. So it's going to be 1 kilogram times 9.8 meters per second squared times 2 meters. So when I multiply that out, it comes out to be 19.6 joules. Oh, I misread that question. A 20 kilogram object strikes the ground with 1960 joules of kinetic energy. Oh, so this is 1960. Whoops. After falling from rest. So now, it's already found that. Whoops. So mgh is equal to 1960. And they gave us the mass, so we have to find the height. So the height is going to be 1960 divided by mg. So it's going to be 1960 divided by the mass, which is 20 times gravity. Oh, and they gave us numbers that are easy because 20 times 9.8 is 196, and then 1960 divided by 196 is 10. So this is 10. So this is going to be B. I was reading the next one on the other paper. All right, so this one is going to be B. All right, so let's look at the next ones. All right, number 13, we have an incline, and it says base your answers to the following diagram. The diagram represents a 1 kilogram object being held. The object is released and slides the length of the incline. When it reaches the bottom, the object's kinetic energy would be closest to. So again, this is conservation of energy. So the total energy before is the total energy after. So at the bottom of the incline, this is base level. Okay. So at the top, if it's not moving, and they show you it's 2 meters, that the potential energy, the kinetic energy is 0 because it starts from rest. Because it says it's released, but it starts from rest. So when we do KEI plus PEI is equal to KEF plus PEF, this is going to be 0. So here I have MGH is equal to, and at the ground the potential is 0 because that's base level, so this is 0. So that's equal to KEF. So if I want to find KEF, it's MGH. So it's going to be 1 kilogram times 9.8 meters per second squared times 2 meters. So 9.8 times 2, KEF is equal to 19.6 joules, which is A. All right, number 14, it says which graph best represents the relationship between the gravitational potential energy of a freely falling object and the object's height above the ground near the surface of the earth. So the first thing I'm going to do is say, okay, I want to know what's the relationship. So gravitational potential energy is mgh. So the question says, the relationship between the gravitational potential energy, this, and its free fall, so it's going down, and the object's height above the earth. Okay? So as the height increases, so does the gravitational potential energy, because this height, these are directly proportional, so the answer is going to be A. So as the height increases, the gravitational potential energy increases. Okay, and that's the only graph. And again, you can see that it's linear. So as this increases, so does this. And then the last one is a force versus distance graph. So I have to say to myself, what do I know about this graph? So on a force versus distance graph, the work is the area under the curve. So the question asked me, what is the total work in 6 meters? So what I'm going to do is I'm going to do this. This is the curve. So first I'm going to do the rectangle, and then I'm going to do the triangle. So the rectangle is base times height plus the triangle, which is 1/2 base times height. So I have 3 times 6 plus 1/2 of 3 times 6. So 6 times 3 is 18, plus 18 divided by 2 is 9, is going to be 27 joules. And that is choice A. So again, when we say base times height, 3 times 6, and then this, 6 minus 3 is 3, so it's 1/2 of 3 times 6. I'm just looking at this. And that's it for the multiple choice on the front.